you, Mr. Chipta, for your kind introduction. Very nice introduction. Um, First of all, allow me to share the screen.
Yes,
Uh, we, sh- Whether you already see the screen right now, Pak Chipta?
Ya, iya Pak.
Okay. Yeah. Okay. First of all, I would like to thank for the National Battery Research Institute for giving me this chance to little bit introduction of battery packaging assembly and also battery management system. Thank you, Prof. Effie, and also all of the colleagues. I think I recognize some of you here, Pak Subhan, and any others colleagues from LIPI, from Batan, and also from maybe my former students like Mas Ian and also Mbak Asi and etc. So I'm happy
Halo.
today. I'm delighted to give this topic. Actually, this is just a rough topic. I'm not really detailed in topic about battery packaging assembly and also battery management systems. I think it's not taking like 30 minutes, and then I think we can have a discussion after that. Okay, this is. I would like to give you some story. I have a little bit experience regarding the battery packaging system. Yeah, in 2017, we were proposing a battery packaging, what we call is tabung listrik. Yeah, at that time, as you may see here, 2017, it was like this green. This is using a green color. Yeah, 2017. That was like the first prototype of what we have tabung listrik. Yeah, and then at the time, since that time, we were collaborating with PLN to use this talis tabung listrik for the electrification in the area where no electrification. Yeah, especially in the eastern part of Indonesia. So we propose that, but of course, product development will always, have a new development in 2019 and 2020, and this year it should be, the budget for from national budget. They have for Ministry of Energy and Mineral Resources. They said, I don't know exactly, like 43,000 these tallies should be implemented, yeah, in 2020 this year's. 30 household will be provided by one, like we call it solar power charger, yeah, because we are using solar power, yeah. So in 2017 we proposed this one with to Pertamina, that in the future actually the business will not rely on the fuel, fossil fuel, but also the business will be, I mean, the energy business will be changed to become like a renewable energy business stream. Yeah, that's why we propose solar power with, at that time we talk, Thalys is Gatrik, yeah, Galon Listrik, like that. So I have also experience regarding the battery packaging when, yeah, it was like 1 or 2 years ago when I was joined with UI to develop, this electric vehicle bus, yeah, EV bus. At that time, I'm in charge for this battery, yeah, system. Yeah, it was very tough. It's very tough actually because we have to use the used battery, and then we have to make the bus running again. So we are doing many things. Yeah, we measure the resistance, internal resistance, also the charge and discharge. And after that, we are using this one to make a new configuration of the battery. So in the end, of course, this bus becoming running again by using the used battery at that time. Yeah, I worked with my student, master student at that time. So this bus is provided by a 115 kilowatt hour with a motor about 60 kilowatt. Yeah, uh, yeah, it's about that. And since 2020, I am going to Sumbawa University of Technology as a rector here. And here also I and my team developing this ngebut. Yeah, this is e-bike. We make it by ourselves here. Now we are now producing for about 100. Of course, there also the battery packaging, yeah, system, and also BMS inside that. So we are using about 700 watt hour battery with about 48 volt until 50 volt lithium ion battery with the battery management system and a control as well. Yeah. So I would like to share with you about the experience, yeah, about how can we develop this battery packaging and also the battery um, management system. Okay, this is kind of definitions. Yeah, battery energy storage. Yeah, value change is actually what we are talking about is in the left side here. Yeah. Okay, just make sure. Yeah, here, uh, if we see the value chains, yeah, we can divide it. Actually, the battery energy storage system for any applications is divided to become the storage technology manufacturer, the power conversion manufacturer, thermal management manufacturer, software control vendor, and many others. Yeah, we can divide it like that. Even, for example, this manufacturer can be also one manufacturer. It is possible like that, but can be also there is one big company, for example, as the assembler, but they also require some certain manufacturer to supply the technology. What we are talking about today is actually only for this pack, battery pack, and battery management systems. There are quite a lot of and also the cells. Maybe this is one system actually. Cells, pack, and battery management system, it is what we call is battery pack. So battery management system is actually one of the component of the battery pack. But also, we have to know that this battery pack cannot be standalone, because they will need the other one, power equipment conversion, for example, the inverter or bidirectional inverter, that is also over there. And also, if we talk about the the storage facilities which very containing very high energy, that should be also the thermal management manufacture system here. So heating, ventilation, and air conditioning system is very, very important in this battery, because we know that battery is really, really depending and also very affected by the temperature. Yeah, we have to keep the battery temperature to become like room temperature or even lower than this room temperature to make a good life cycle of the battery. And also software control development and many others. Here is there is also another thing that we have to provide in this system. So today what we would like to talk is, perhaps the cells has been explained by previous one, Professor Agus. We're talking about the pack and the battery management systems. Okay, this is the battery pack definitions. Actually, the battery pack definition is that is the sets of battery or series of battery and parallel of batteries that is ready for use, contained in a rigid and enclosure with protective device, battery management system, and thermal control system. That is what we call is battery pack. Yeah, this is the battery pack, for example, for the car. Yeah, for passenger car or any other device. Yeah, even for submarine also, actually they have a battery pack, but this is just quite different, of course, with the electric vehicle, because submarine using very high capacity of the battery. Yeah, so actually they also battery pack. There should be also the battery management system for the battery pack. So that is the battery pack definition. So what is the component in battery pack? Yeah, your development from France, they provide these, categories for the battery pack. The first one is what we call a safety component. The safety component is containing the sensors. Yeah, this is mostly actuators. So these sensors is required, yeah, whether you have a current sensor, voltage sensor, or maybe pressure or temperature or any others, and also contactor relays and etc., including the fuses, of course, for the safety. Um, they become one component of the battery pack. This is very important to protect the battery itself, yeah, because the battery should be protected by this one, yeah. If the sensor are broken, then this is very dangerous for the battery, yeah. So there should be another safety component which protect. So actually this is kind of cascading, yeah. In a very modern car, for example, even the fuses is not like this one. Actually the fuses, they are using the wire, only wire, because when there is a short circuit, for example, which induce the very huge current, they automatically um apa like melt down, yeah, melebur, like that. So they're using a certain like wire in order to make this is also the connector. The function is the connector or the conductor, but in the same time they also become fuses. Now, you can see in the car, yeah, in the EV car right now using that. And the other thing is BMS. So I told you that BMS is one of the component of the battery pack, and the cell itself. I think we have already learned from the previous speakers, and also the electrical interconnect, because the cells are contain quite a lot of cells over there. They have to be interconnected whether in series or parallel. There should be a bus bar and also the cable or the connectors, the socket. It is one of the very important. And in the electricity people, all the problem, or not all the problem, most of the problem in electricity systems is actually jointing or connection, because that is two material which has different characteristic. Jointing, for example, they will uh, make a problem. So this should be very good in electrical interconnect. And the other thing, when we are talking about very large system, there should be a thermal management. Yeah, water cooling, whether we can use the water cooling or any other fluids, and also the thermoelectric modules, for example, air cooling or thermally conductive gel, yeah, in order to prevent the heat, for example, because during the charge and discharge, as you may explain before, there is an excess of heat, yeah, generated by the reaction, electrochemical reaction. And also last but not least, but very important, is the housing. This is, the housing is very important also, in order to protect the system to become more reliable, more safe for the battery and also for the environment. Housing is important, and also it also should be artistic, in my opinion, in order to be ergonomic. Yeah, this housing is very important. Then this all call battery pack. This is just the example of a battery pack. You may see in the car like this, in your under your seat, there will be a battery pack over there. Quite lots of battery like here. For example, here for Opel Almera e-car and its battery pack, it's containing 140 watt hour per kilogram. Yeah, and 126 watt hour per kilogram. So you can imagine how many kilowatt hour, for example. The total energy depends on the weight of this battery pack. And here you can see the battery pack for many applications. Yeah, for renewable energy right now, there are very huge development for the battery energy storage system, BESS, because the battery is really important in order to be, mixed with a very fluctuative renewable energy like wind power or solar power, and they provide quite large of energy, more than 200 kilowatt hour. But if you see here, actually it's similar. All of the principle is similar. They have to contain the safety component, they have to contain the thermal management system, battery management system, and also the housing. For the large one, we are mostly the manufacturer using the container like that, like 40 container or 20 container feet. They are mostly using that one. And also there should be a thermal management system, the cooling system should be over there. And you can see this is a plug-in hybrid electric vehicle battery pack, and many other battery pack are now developing with more and more energy storage system. Yeah, including we can see, for example, Tesla also already have a product for residential pack, and many other company also using that one. Okay, now, one of the component is the thermal management system. That is, thermal management system is very, very important because the battery is really, really depending on the temperature operation. When we cannot manage the temperature operation is in room temperature, for example, let's say 25, 27 degrees Celsius, then the life cycle will be degraded gradually and rapidly. Yeah, even for example, one stationary battery station, battery energy storage system, which is stationary, mostly the manufacturer can provide like 10 years of life cycle. But when the temperature is increased like more than, for example, 30 until 40 or until 50 degrees Celsius, then the operation, no, the life cycle will be degraded very rapidly, even, for example, 1 year or less than 1 year of life cycle. So this is very important for this one. So in order to design the thermal management system of the battery pack, we have to know about the input parameters, the application type. For example, whether this one is stationary or whether this one is mobile. Okay, the battery energy storage system is actually when we applied for the electricity system, for example, this is stationary. Mostly they are located nearby the power plant or the transmission system. They are stationed. But for electric car, for example, they're mobile. And also, we also have the similar battery energy storage system with mobile container, for example. We actually have proposed this one to PLN because sometimes in one island in Indonesia, Eastern Indonesia, they are lack of the electricity, but they're difficult to build, for example, power plant nearby them. For example, lack of the resources, for example. Now we are proposing with using mobile energy storage system. The concept is when there is electricity, the excess of electricity in one island, they can be charged. There should be a very cheap electricity price. Then we can use this one to the other island by using, for example, the car, the truck, or container truck, or we can also use the vessel, yeah, the barge, barge or vessel, yeah. They can also using this vessel to come to the other island, then distribute it to this island. Once it is the charge is empty, and then we can go back to the other island for charging, for example. That kind of option is also now we are considering that kind of option. There are also environmental temperature. I saw you that the temperature is very important, especially when you install in the area of tropical country or the area where, yeah, quite a lot of sun exposure. And also basic chemistry, different of type chemistry of the battery. Yeah. For example, what material are you using? Whether you are using NCM on MC or NCA and any other LiFePO and any other materials. This is also depending on the thermometers because different characteristic. And battery cell format and size. Cell formats mean, we have like prismatic one, we have the cylinder one, and many other format, and also the size. Yeah. How big size is it? How many ampere hour? How many kilowatt hour? So this is very important to make the thermal management system. And also the requirement of charge discharging. How many C rate are you using for charging and discharging for this requirement? And also acceptable cost, of course, that should be compromised. And there will be another technology solution. For example, we are using the passive or active balancing system. Yeah, I will talk to you later about this balancing system because balancing system is very important. Balancing system is really, really important for the battery packaging. I always give the analogy about this when we are using many walls to untuk menarik train, ya, if one wall is sick, then this will affect to the other walls, or not walls, maybe like horses, maybe like that. If one horses is sick, maybe that will be causing to the other, that will be affecting to the other horses, even make the system or the horses all falling down. For example, like that. It's also happening in this battery management system. Balancing is very important. And we have passive and active uh, balancing system. And the second one is whether we can use liquid or air or refrigerant or any others fluid, and cooling fluid and surface cooling and additional thermal cooling, conductive, isolative, and thermomodular. So again, in order to enhance the life cycle, battery thermal management system is the key to answer this one. Okay, the other thing is in battery management system, we have to reduce the losses due to heat. Yeah, this is very simple equations that losses is proportional to the current and also the square of current and also with the resistance. Yeah. If resistant internal cells, yeah, these two resistance, yeah. First is internal resistance from the cell. Cells containing the electrode materials, which is also have separator and also they have also electrolyte. They are actually can be considered as resistance. Yeah, we have to be as long as the resistance can be lower, then the heat loss also can be minimized. And the other thing is that we have also resistance in the interconnect. Yeah, I already previously explained that we have for example, the copper or the nickel plate for connecting each poles. Yeah, it's like positive to negative and etc. That is also have the resistance. So we have to consider about that. So in order to minimize or to reduce these losses, we can choose, yeah, the cell with low internal resistance. For example, um, thick internal deflector, thin electrochemical active layers, high conductivity of active layers, and the electrolyte and the separator. We can also find out which is the low internal resistance. And also, we also have to provide high voltage battery cells in order to high voltage battery cell will reduce laterally, will reduce the current, yeah, at the same time. So with high voltage is preferable in order to, decrease the heat. And also high voltage is actually related to the energy that the battery can be stored. The higher battery voltage is corresponding to the higher energy. And also higher battery pack is also preferable, and high conductive materials like copper jointing, and this is for interconnection. Okay, so when we are designing the battery pack, what is the factor affecting the battery pack cost? Of course, the first one is the energy power power of the cells. Whether we would like to charge and discharge with very fast charging or discharging, it's also depending of the battery cell, because the battery cells is including the battery pack. This is very important. So that is why you have, when we are designing the battery pack, you have to know the loads or the characteristic of the battery pack for what purpose you are making this battery pack. And the other thing is that the product characteristic tolerance. Yeah. So for example, it's also related with the energy. Yeah. The energy, how many percent energy you want to discharge from the battery. It's also important. The safety itself. Yeah. Because different material of battery will have different. For example, when you are using NCA, lithium cobalt aluminum, yeah, nickel cobalt aluminum, it will have a very high of voltage that also risk to the safety. Yeah, cycle life, temperature management type, conventional or conditional capable, as well as BMS type. Not all of the BMS type is fit for all batteries, because we have to know BMS also, I will talk you later about BMS, okay? So also process volume and many other, yeah, partnership, leader, follower, small player, etc., etc. But regarding the cells, yeah, I have suggestion for you. If you want to make a battery cells, please be careful about this battery, because yeah, we cannot see inside the battery, so we have to know the characteristic of the battery. So you have to confirm that the battery you are buying is having the very good characteristic of the battery. That is my tips, yeah, for making the battery pack. So in my opinion, the good branding, the good brands of the battery, that is also reflecting to the good quality of the battery. In my opinion, in my experience, like that. Now, actually, there is no standard for the battery pack. Again, there is no standard of battery pack. No, every manufacturer can make their own. Yeah, and this is why, because like this is challenging in a DC power. Battery is a DC, right? So in DC, we don't have a standard of the voltage. In AC, we have already 220 volt, but the DC we have different. For your EV, for example, we can use how many voltage? Like 300 volt, for example. For telecommunication, like 48 volt. For your laptop, it's 19 or 18 volt. For your handphone is like 5 volt, and many others. Yeah. So we have difficult, but there is one characteristic which is the same, that the modular approach for battery pack are now many people developing, including our stylist is actually modular. So we hope the stylist can also, not only for the electrification in the house, but for the housing, but also for the car, maybe for an electric car or the motorcycle, scooter, or any others. Yeah. So the approach is try to make the modular one in order to be easily charging and also discharging. So now many manufacturers are using this modular battery pack. Yeah. Okay, now we can see the direction of battery pack development. Mostly is related to integrated thermal management control. Thermal management control of battery pack is very important because maximum operating temperature is more now is try to more than 85 degrees Celsius. Yeah, so which means that the battery more than 85 degrees Celsius needs a very good thermal management system, and also vibration resistant BMS. This is for the BMS containing the electronic devices which need vibration resistant characteristic, because when it is not vibration resistant, then it will be difficult for the battery running very well. So BMS is very important. It's kind of the heart of the battery, kind of the brain of the battery, kind of the doctor of the battery is BMS. So BMS should be very reliable. So more research are devoted for this vibration resistant BMS, and better heat dissipation, yeah, of the BMS PCB. Proto board PCB is very important in the BMS, but heat dissipation, because it's containing many electronic devices. There is many IC, there is thyristor and any other device, electronic one. So it should be good the heat dissipation, and also active cell balancing right now. I will let you know about this balancing later. And BMS solution also progressing, and faster communications. Yeah, this is software and also connecting communication is very important for this battery pack. So the research and development are more devoted on this area. Now I'm talking about the BMS just a little bit. BMS is very important for the battery system. As you may see here, we have the battery 3 series and 2 parallel. As you may know that in series means that the voltage is increased, is added, but for the parallel, the current is added or increased. Yeah, but the voltage is almost same. So what is the function? The protection and prevention of the system from the damage. The second one is the increase of battery life, maintenance of the battery life in accurate and reliable state, and we call it the battery BMS is battery doctor. Yeah, the doctor has stethoscope, for example, to see whether this person's disease or something like that. They are very smart. They know the health of the battery through this BMS. So the functionality, when you are powering up, for example, when the powering up, it always use the relay to be connected by BMS. Yeah, because mostly the current is really high. That's why we need the relay and also the sensing system in order to powering up. And what BMS doing is measuring. What they measure first is voltage or temperature or current, and diagnosis and pack for the pack system itself. The cell, the pack or the system, and also the master, and make a diagnosis, measuring, and then gathering the data. Yeah, voltage, current, temperature, mostly like that, because this is an important part of that. There is no other sensors. Yeah, mostly just using for this one, and they calculate. They kind of computer. They calculate like a calculations, doing a state of charge, state of hot, and power limit, balancing the verification. And they also can do analysis and judgment and control and etc. here, and also powering down. Yeah, and they can save the data. And one more important thing here is that when the battery is damaged or something, they can be also restored, can be recovered. Yeah, the data or something, database or any other data, current, voltage, etc., where can be stored in this BMS. So very smart system in order to protect this battery system. So the key function, I think I already have. Yeah, even BMS. This is battery fact in here in the corner here. They measure everything, but they can go to the BMS, and these BMS also mostly are also embedded with the other function to the motor controller, to cooling system element, auxiliary charger, for example, the safety system, or even for the data history, you can embed it to the laptop, or there is a port in order to take the data for the PC or the laptop. That is mostly there is a signal on off or DC voltage and current, signal on off, status signal, and etc. Here is one of very important thing in designing the battery pack. Yeah, there's two balancing system. First is active, passive balancing system, and the other one is active balancing system. The passive one is actually when the one battery is higher of voltage. In order to make balance the battery with the other cells, they are using resistor. Yeah, whether to fix something resistor or switching resistor. So this resistor to become heat. Yeah, so we can reduce the battery capacity, the battery energy by using resistor to become heat. But for the active one, the difference is that we just use this energy not to be converted to become heat, but they are converted they are filling the other battery which is not which is empty or not you know similar energy. So, for example, the higher energy of the battery, they are transported or they are extracted from the battery which is higher to the lower one and make a balanced one. So that is capacitor base, inductor or transformer base, or converter base. You can use to the make a lower voltage, then the energy will flow from the higher to the lower one, and finally it will make a very balanced one. Yeah, that is the difference between passive and the active one. I think I thank you. On this occasion, I would like to say deepest condolence to our family, National Battery Research Institute, because of this is a great loss of Dr. Bambang Priandoko. We are very sorry for this one. He is very excellent researcher for us here in battery field in Indonesia even. So we are very sorry for this one. We hope that he is Husnul Khotimah, and also his legacy always be in our family in National Battery Research Institute. Thank you so much.